Out here, in the cold and silent darkness of space, something truly remarkable is unfolding. Far beyond our own moon, a million miles from the familiar blue and white marble of our home, a magnificent golden eye has opened. It floats in a delicate, lonely dance with the sun and the earth, a sentinel poised to peer back into the very dawn of time. This is the James Webb Space Telescope, a creation of human ingenuity and boundless curiosity. It is our most ambitious attempt yet to understand the universe and our place within its staggering, beautiful emptiness. It does not look for what we know, but for the questions we have not yet thought to ask. This telescope is more than just a machine of glass and metal. It is a time traveller. Its gaze is fixed on the most distant reaches of the cosmos, where the light from the very first stars and galaxies has been journeying for billions of years to reach us. To see this ancient light is to witness the universe in its infancy, a time when everything we see around us today was just beginning to form from cosmic dust and gas. The mission of the James Webb Space Telescope is one of pure discovery. It was built to answer some of the most profound questions we have ever posed. For over 3 decades, the Hubble Space Telescope has been our faithful eye in the sky. It has gifted us with breathtaking images of swirling galaxies and ethereal nebulae, fundamentally changing our perception of the cosmos. But science, like nature itself, is always moving forward, always evolving to see more clearly. The James Webb Space Telescope is not a replacement for Hubble, but its successor. It is designed to see the universe in a way that Hubble cannot. While Hubble primarily observes the cosmos in visible and ultraviolet light, much like our own eyes, Webb is tuned to see in infrared. Infrared light is essentially heat radiation, and it can travel through the vast clouds of cosmic dust and gas that obscure many of the universe's most fascinating secrets. Webb's vision allows it to pierce these veils, revealing the hidden nurseries where stars and planets are born. This light has travelled for so long and from so far away that its wavelength has been stretched into the infrared part of the spectrum, making it invisible to Hubble. So while Hubble gave us the grand, sweeping portraits of the mature universe, Webb is giving us its baby pictures. Together, they form a more complete picture, spanning from the fiery beginnings of creation to the elegant, sprawling structures that now fill the heavens. At the heart of the James Webb Space Telescope is its magnificent primary mirror. It is a breathtaking sight, a giant honeycomb of 18 hexagonal segments, each coated in a microscopically thin layer of pure gold. Spanning over 21 feet, it is the largest mirror ever sent into space, designed to collect as much light as possible from the faintest, most distant objects in the universe. To see the faint infrared glow of the early universe, the telescope must be kept incredibly cold. Any heat from the telescope itself would blind its sensitive instruments, like trying to take a picture of a candle while standing in front of a searchlight. To solve this, engineers designed a colossal sun shield the size of a tennis court. It is made of 5 layers of a special material called kapton, each layer as thin as a human hair. The telescope's location is just as remarkable as its technology. Webb does not orbit the Earth like Hubble does. Instead, it orbits the Sun, a million miles away from our planet at a special spot known as the second Lagrange point, or L2. At this unique point in space, the gravitational pull of the Sun and the Earth balance perfectly, allowing the telescope to stay in a stable position relative to us. Getting this colossal, delicate instrument into space was an incredible feat of engineering. The mirror and sunshield were too large to fit into any existing rocket, so they were designed to fold up like a piece of intricate origami. After its launch, Webb embarked on a complex, month-long journey of unfolding. Each mirror segment, each layer of the sunshield had to deploy perfectly, controlled by hundreds of motors and mechanisms. Its successful deployment is a testament to the meticulous planning and dedication of thousands of people. Our eyes are wonderful instruments, but they are limited. We can only see a tiny sliver of the full spectrum of light that fills the universe. Beyond the familiar colors of the rainbow lies a world of invisible light, from radio waves and microwaves to X-rays and gamma rays. The James Webb Space Telescope is designed to see in one of these invisible realms, the infrared. By looking at the universe in infrared light, we can uncover secrets that have been hidden from us since the dawn of astronomy. One of the greatest powers of infrared vision is its ability to peer through the immense clouds of cosmic dust that are scattered throughout our galaxy and beyond. These clouds are the birthplaces of stars and planets, but they're opaque to visible light, hiding the processes happening within. Infrared light, with its longer wavelength, can pass through this dust, much like radio waves pass through the walls of a building. This allows Webb to look directly into the heart of stellar nurseries, to watch as new suns ignite and planetary systems begin to form from swirling disks of gas and dust. Infrared light also holds the key to looking back in time. The universe is constantly expanding, and as it expands, it stretches the light that travels through it. Light from the most distant galaxies, the very first ones to form after the Big Bang, has been travelling for over 13 billion years. Over this immense journey, its visible and ultraviolet light has been stretched so much that by the time it reaches us, it has shifted into the infrared part of the spectrum. Furthermore, infrared observation is essential for studying planets outside our solar system, known as exoplanets. More importantly, Webb can analyze the starlight that passes through an exoplanet's atmosphere. By looking at which wavelengths of infrared light are absorbed, scientists can determine the chemical makeup of that atmosphere, searching for water, methane and other molecules that could be signs of a habitable environment. It is a powerful tool in the search for life beyond Earth. In the grand scheme of the cosmos, our solar system has a very near neighbour. Just over 4 light-years away lies Proxima Centauri, the closest star to our Sun. It's a small, dim red dwarf, a faint ember compared to our own star's brilliant fire. For a long time it was just another point of light among millions. But then in 2016 we discovered something extraordinary. Orbiting this nearby star is a planet, a world named Proxima b. This discovery electrified the scientific community. A planet right on our cosmic doorstep raised tantalizing questions about the possibility of other worlds like our own. What makes Proxima b so fascinating is its location. It orbits its star within the habitable zone, sometimes called the Goldilocks zone. This is the region around a star where the temperature is just right, not too hot and not too cold, for liquid water to potentially exist on a planet's surface. And where there is liquid water, there is the possibility of life as we know it. However, there are many challenges for life on Proxima b. Its star, Proxima Centauri, is a volatile red dwarf. These stars are known to unleash powerful flares of radiation, which could strip away a planet's atmosphere and sterilize its surface. The planet is also likely tidally locked, meaning one side always faces the star in perpetual daylight, while the other is locked in an endless frozen night. Before the James Webb Space Telescope, Proxima b was little more than a shadow, a wobble in its star's light that told us it was there. We knew its mass and its orbit, but we knew nothing about the planet itself. Did it have an atmosphere? Were there clouds? Did it have water? Proxima b represented a profound mystery, a world so close yet so completely unknown. It was the perfect target for our new, powerful eye on the cosmos. A place to test its incredible capabilities and perhaps make a discovery that would change everything. The moment the James Webb Space Telescope turned its golden mirror towards Proxima b was one of quiet anticipation for astronomers around the world. For years, this nearby world had been a tantalizing enigma, a prime candidate in our search for life beyond Earth. The telescope's powerful instruments were designed for exactly this kind of work, to capture the faint light from a distant planet and dissect it for clues. Using a technique called direct imaging spectroscopy, Webb blocked out the blinding glare of the parent star, Proxima Centauri, allowing the faint glow of the planet itself to be seen for the very first time as a distinct point of light. What Webb revealed in that first observation was breathtaking. It was not a detailed photograph like one of Earth from space, but something far more meaningful. The telescope gathered the planet's faint infrared light and spread it out into a spectrum, a rainbow of information that held the chemical fingerprints of its atmosphere. The data streamed back to Earth 1 million miles away, and as scientists analyzed it, they found what they had been hoping for. The spectrum showed the unmistakable signature of water vapor. The presence of water, a key ingredient for life, was confirmed in the atmosphere of our nearest exoplanetary neighbor. But the discoveries did not stop there. The detailed spectrum provided by Webb's instruments revealed more than just water. It also showed the presence of carbon dioxide and, remarkably, trace amounts of methane. On Earth, methane is a gas that is overwhelmingly produced by living organisms. While it can be created by geological processes as well, its detection in the atmosphere of a potentially habitable world is a profound and exciting clue. The data also gave us our first hints about the planet's climate. The composition and density of the atmosphere suggested that Proxima b is not a barren, airless rock. It has a substantial atmosphere, thick enough to potentially protect the surface from some of the star's harsh radiation and to circulate heat from the sunlit side to the dark side. In a single observation, Webb transformed Proxima b from a statistical probability into a tangible, dynamic world. The story of the James Webb Space Telescope and its first glimpses of Proxima b is not an ending. It's the very beginning of a new chapter in our cosmic journey. With every new observation, this incredible instrument is peeling back another layer of the universe, revealing wonders we had only dreamed of. It's looking back to the dawn of creation, watching as the first galaxies ignite in the darkness. It's peering into the hearts of stellar nurseries, witnessing the birth of suns and worlds. And it's tasting the air of distant planets, searching for the faintest hints of life. What other discoveries await us? The telescope's mission is long, and its gaze will turn to countless other targets in the years to come. It will study thousands of other exoplanets, each one a unique world with its own story to tell. It may find planets made of diamond, worlds covered in global oceans, or even rogue planets wandering alone through the dark cold of interstellar space. Perhaps one day, Webb will find something truly definitive. It might detect a combination of gases in a planet's atmosphere, oxygen, methane, and water vapor together, that would be very difficult to explain without the presence of a living biosphere. Such a discovery would be one of the most profound in human history, fundamentally altering our understanding of our own existence. For now, we can only look up at the night sky with a renewed sense of wonder. Out there among the countless points of light are worlds we are only just beginning to know. The universe is not a static, empty void, but a dynamic and evolving place filled with possibility. The James Webb Space Telescope is our messenger, our scout sent into the great unknown. And as we wait for the stories it will send back, we are invited to imagine what comes next. What other secrets are hidden in the dark? What new questions will we learn to ask? The sky is full of stars, and each one is a promise of a new discovery.